Hello students, welcome to day 42 of 99% in 99 days for your class 10th board. So students, exams are very near and revision and mock test are equally important, right? So today we are going to discuss the answers of the mock test 6 that we conducted on Sunday, right? So I hope all of you would have downloaded the question paper from the WhatsApp community or from the YouTube channel community post. If you haven't, please download it right now, solve the question and then watch this video to see the solutions. Okay, so yes students, I'll be discussing in the first part carbon and its compound, whatever study we have done only one lecture in this week, right? So whatever we have discussed in that particular lecture, based on that we will practice some questions, and after that Soumik sir, your physics teacher, will be discussing the solutions of electricity. Okay, so yes students, now let's get started here. So question in this particular session you will be getting 6 MCQs, okay, 2 marker questions, 2 questions I'll give you, 3 marker 2 questions I'll give you, and 1 5 marker and 1 4 marker questions we will give. So total comes out to be 25. I'll be telling you the marking scheme as well, so you need to put your mark yourself, score yourself and comment down your total score. Okay, let's get started. Okay, so students, here I want to remind you about something called as DSAT. You might have already known about this. We have told you in many of these videos, right? So the DSAT stands for Diksha Scholastic Aptitude Test. So students, now as I told you, you are in your 10th standard, and after the 10th exams are over, you need to make a very important decision regarding your career. So students, now I want to tell you about something called as DSAT, which stands for Diksha Scholastic Aptitude Test. Now students, all of you know that once your 10th exams are over, results are out, you have to make a very important decision regarding your career, right? And this decision is very vital, as it is going to be affecting your next 4 to 5 years of career, right? So to help you with this, we have launched DSAT, in which you get a 60-minute lecture. Then you need to write a test on that lecture that you have attended, and this test will be evaluated and you will be having a one-on-one mentorship where you will be told about your strength and weakness and which career is the right choice for you. Okay, so students, if you do not want to make any mistake in choosing the best career for you, do not delay. Go to the description section, click on the registration link, register for DSAT and choose the best career for you. Okay, fine. Now let's get started with our questions. The first question is regarding the covalent bonding. Nitrogen molecule. I have given you the same example of nitrogen molecule. If you remember, nitrogen has 3 bonds. So how many electrons will be there here? Each bond has 2 electrons. So 3 bonds will have 6 electrons, right? So here I can find 5. So this I will eliminate, 4 eliminate. Here 6 is there, here is also 6 there. But again, nitrogen octet should be satisfied. Now if you see 6, 7, 8, 6, 7, 8. Yes, this can be the answer. Here 6, 7, 8, 9, 10, 11, 12. Nitrogen is having 12 electrons here. So that is why this will not be the answer, and the correct answer is option number A. C. This I'll put the options here. This is A, this is B, C and D. Okay. Next, the picture shows the incomplete chain structure of a carbon compound. Okay, the second carbon atom has how many free electrons? Okay, so now if you see, the first, it has formed 2 bonds, right, and 2 electrons are free here. The picture shows the incomplete chain structure of a carbon compound. The second carbon, C2 atom, has how many free electrons? You can see it has 2 free electrons, right? So option number B is the correct answer here. Next, a part of a homologous series is shown below: C3H4, C4H6, C5H8. Okay, which of these compounds is a part of the series shown above? Okay, so if you see, we have C3H4. Next, you added 1 C and you have to add 2 hydrogens. Then you have C5 and H8, right? Next, if you see, if you have C6, okay, then what it will have? C6 will have H10, right? So that is why this is not correct. And you see, number of hydrogens is more than number of carbon, so this also cannot be the answer. C2, if I have C2, then H should also decrease by 2, right? sorry, yeah, we are increasing this one, so it will be C2H2, right? I think that is correct. Yes, C2H2 will be the next, will be the first member here, right? You can see here we are adding CH2, then I'll get this one. CH2 if you add, you will get this compound. So if I subtract CH2 from here, 1 carbon and 2 hydrogen, I'll get C2H2. So A is the correct answer here. Next, which of the following is not observed in a homologous series? Give reason for your choice. So change in chemical properties? No. Homologous series have the same functional group, right? So they have similar chemical properties, so there is no change in the chemical properties. Difference in CH2 and 14U molecular mass? Yes, this is the correct answer. Gradation in the physical properties? Yes, physical properties changes and same functional group is also there, right? Is not observed. Okay, so not observed you have to write. So this is observed, this is observed, this is observed. Change in chemical properties is not observed because they have the same functional group, right? Why? What is the reason here? Because they have same functional group. Okay. Next, question number 5, assertion reason. I missed 1 second. Okay. Next, following are the structure isomers of butane. Okay, structural isomers have the same molecular formula but they differ in their structures. Okay, so you can see you have butane here. Okay, both of them have the same formula C4H10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, they have the, now how we can call them isomers? Because they have same molecular formula but differ in their structures. Yes, that is correct. So both assertion and reason are correct and reason is the correct explanation of the assertion. Okay. Next, third member of the alkane is propane. It is obtained from the general formula CnH2n plus 2. Yes. So that is also correct. If you substitute here N3, 3 to the 6 plus 2, 8. Yes, both assertion, reason correct. Reason is the explanation for the assertion, right? Okay. Next, we'll go to some short answer type questions of 2 markers. Okay, these are your 2 marker questions. Now, the table shows the electronic structures of 4 elements P, Q, R, S. Identify which element will form covalent bond with carbon. So now carbon is an element. Remember, it forms covalent bond with another non-metal. Okay, and in metals and non-metals we have discussed that non-metals have 5, 6 or 7 electrons in their valence shell. Okay, so now let us consider, okay, so this has 6 valence electron, so this can form a bond. Here it has 1 valence electron, so this is a metal. Okay, 1 valence electron means it is a metal. So carbon will not form covalent bond with metal. So this is wrong. Okay, now 7 is there, so this can also form, and its octet is already satisfied, right? This element octet is satisfied, so it won't form any bond. So which 2 elements we will get? P and R. Okay, so which 2 elements? P and R. Okay. Next, carbon reacts with an element in the above table to form several compounds. Give suitable reason. So we have already discussed why carbon can form so many bonds. So there are 2 reasons here. One is the catenation property of carbon, right? Another is about its tetravalency. Okay, fine. Next, question number 8. Give a test that can be used to confirm the presence of carbon in a compound. With a valency of 4, how is carbon able to attain the noble gas configuration in its compounds? So this is also a very easy question. So if a carbon is containing if a compound is containing carbon, okay, if you burn it, then what we will get? We will get CO2, and CO2 gas which is produced can turn lime water milky. Okay, what is lime water? Lime water is calcium hydroxide. Okay, and if you pass carbon dioxide gas through this one, you will get calcium carbonate. Okay, which this calcium carbonate turns the lime water milky. Okay, next, with a valency of 4, how is carbon able to attain the noble gas configuration in its compound? Okay, so by sharing the 4 valence electron. So carbon has 4 valence electron, right? We just discussed in the last class that why carbon cannot donate these 4 electrons or cannot gain 4 electrons, right? It can only share 4 electrons. So with a valency of 4, how is carbon able to attain the noble gas configuration? By sharing of electrons. Okay, by sharing of electrons with other elements. Okay, Next is your 3-marker type question here. A carbon compound A having a melting point of 156 Kelvin and boiling point of 351 Kelvin with molecular formula C2H6O is soluble in water in all proportions. Identify A and draw its electron dot structure. So when it is soluble in water, okay, the functional group which is soluble in water with one oxygen is nothing but alcohol. Okay, so C2H6O means you have 2 carbon, so I can draw like this, CH3, okay, then CH2OH. You can see 2 carbon, 1, 2, 3, 4, 5, 6 hydrogen and 1 oxygen. Now you have to draw what? Electron dot structure. So you can draw like this. We have C, okay, 3 hydrogens are there. We'll do 1 more carbon, right, and 1 more oxygen, okay, and 1 more hydrogen, right. Next here I can erase this and I can draw hydrogens here, okay. Yeah, so we can have here this side 3 hydrogens, 1, 2 and 3, right, CH3. This side I have 2 hydrogens, okay. So now you can see in this there will be 2 bond, here there is 2 bond and here there is 2 bond, here we have hydrogens, okay, 2 bond, 2 electrons, 2 electrons and 2 electrons, okay. So you have 1, 2, 3, 4, 5, 6, 7, 8 and here you have 2 electrons. Oxygen we have, right, 1, 2, 3, 4, 5, 6, 7, 8. So this is the electron dot structure of this compound. So what is A here? A is CH3, CH2OH and we will call it ethanol, right. Next, give the molecular formula of any 2 homologous of A. So you can just subtract. So if A is this one, okay, homologous, I want to write one previous member, means I will remove this CH2 group. So this is one member and next member means I will add one CH2 group, okay. So this I can obtain by minus CH2 and this I can obtain by plus CH2 group. So this can be one member and this can be a member, okay, clear. Next is question number 10. What are allotropes and how many types of allotropes of carbon are present? So we know allotropes are the different forms of the same element and carbon has 3 allotropes: diamond, graphite and fullerene, right. Next, how will you prove that C4H8 and C5H10 are homologous? So you can see there is a gap of CH2 group. They have same physical properties, they have same chemical properties and different physical properties. Any 2 point or 1 point you can write down. Okay, so allotropes are the different forms of the same element having different physical properties. The 3 allotropes of carbon are graphite, diamond and fullerene. Now, how will you prove that C4H8 and C5H10 are homologous? They differ by 14 U molecular mass. They have same functional group and they have same general formula. Okay, clear? Next is long answer type 5-marker question, this one. So the formula of the 4 organic compounds are given below: C2H4, CH3, COH, C2H5OH and C2H6. Which one of these compounds, A, B, C or D, is a saturated hydrocarbon? So for saturated hydrocarbon, you know the formula of alkanes is CnH2n plus 2, right? So here it is 2 2s are 4 plus 2 6, C2H6, okay. So the first one will be C2H6, right. This is a saturated compound. Next, identify the organic acid and gives its structural formula. You know COH group, it is the acid. So which is the organic acid? That is compound number B. This is compound number D, right? And you have to draw its structure. So it is CH3, C double bond O, OH, okay. Next, which of the above compounds when heated at 443 Kelvin in the presence of concentrated H2SO4 forms ethene as the major product, okay. So you can see ethene, alcohols on dehydration will give you ethene, okay. So I can write the third one is C, that is C2H5OH, okay. But the question is also asking you to which of the compound written, what is the role of concentrated H2SO4? So the role of concentrated H2SO4 is it acts as a dehydrating agent. It helps to remove the water molecule, okay. Next, also write the chemical equation involved. So if I want to write the chemical equation, it is C2H5OH in presence of concentrated H2SO4. Okay, you will get CH2 double bond CH2 and water molecule will be removed. Okay, next the fourth one here, give a chemical equation when B and C, that is one acid and a alcohol, right, react with each other in presence of concentrated H2SO4. So this one will give you what? Ester, right? So you can react CH3 C double bond OH, okay, plus H CH2 CH3. Okay, now here what happens? Here there will be a loss of water molecule. Okay, so we will get CH3 C double bond O O, then we have CH2 and CH3. Okay, now name the major product formed. The major product formed, this one is called as ester. Okay, and mention one of its important use. So esters are used as flavoring agent. Okay, they have very sweet smell, so they can be used as flavoring agent. Okay, this is the use of ester. Okay, I hope all the answers are clear. You can take a screenshot. Okay, next, when coming to the last question here, Rahmat classified the reaction between methane and chlorine in presence of sunlight as a substitution reaction. Okay, support Rahmat's view with suitable justification and illustrate the reaction with the help of a balanced chemical equation. Okay, so if you see the reaction of methane, okay, with chlorine, product formed here will be, it is in the presence of sunlight, so you can write like this H nu to represent sunlight, or you can write down sunlight. Okay, so this gives you CH3Cl plus HCl, right? So support Rahmat's view with suitable justification. So what is the justification here? Chlorine, or you can write chlorine, sorry, you can write hydrogen of CH4, okay, is substituted by Cl, right? So that is why this is a substitution reaction. Okay, then you have written a balanced equation also, CCH4Cl2 balanced. Now chlorine gas was prepared using the electrolysis of brine solution. Write the chemical equation to represent the change. Okay, so chemical reaction, if you want to write here, this chemical reaction we have studied already in the metals non-metals chapter, right? So if you have NaCl, okay, plus water, and if you provide electricity, okay, I'm just writing like this, so you will get NaOH, okay, plus H2 gas and Cl2 gas. Okay, next you need to check whether it is balanced or not. 2H2, 2H2, we need to balance it. Okay, 2 NaCl, 2 NaOH, 2 Na, 2 Na, 2 chlorine, 2 chlorine. Then I have 2 hydrogen, and 2 oxygen. Okay, I have 4 hydrogen, so I'll make it 2. So I have 4 hydrogen, here 4 hydrogen, 2 oxygen, 2 oxygen. Okay, so this is the balanced reaction. Next, identify the other products formed. So what are the other products formed? The other products are hydrogen, chlorine and NaOH. Okay, these are the other products formed in the reaction. Okay, fine. So okay, so students, these were the questions that we have discussed in the chemistry part. Okay, and now the solutions of the physics part will be discussed by Soumik sir. So please watch the continuous video so that you can understand the solutions of mock test of your physics from the chapter electricity. Okay, so that's all students, thank you.
So hello, let's continue with the physics part of the question paper. So as you know, there are 6 MCQ questions. There are 2 2-marks question, 2 3-marks question, 1 5-mark question and 1 4-mark question from physics chapter electricity. So total marks in today's exam was 25 from physics. So let's start with the MCQs. First, a cell, a resistor and a key and ammeter are arranged as shown in the given circuit diagram. The current recorded in the ammeter will be maximum in 1, maximum in 2, maximum in 3, the same in the all cases. Now if you see, so basically what but you can see that the battery is same, ammeter is same, resistance is same, the key is same. Only thing is their arrangement is slightly changed, right? So arrangement is slightly changed, so they will have the same current no matter how they are arranged. The current will be same in all the three cases, so the same current in all three cases, right? Now next question, assertion reason based question. Electron move from lower potential to higher potential in a conductor. Okay, so electron moves from lower potential to higher potential, the current flows from higher potential to lower potential. A dry cell maintains electric potential difference across the ends of a conductor, so that is also correct. So dry cell maintains the electric potential difference across the ends of a conductor, but that is not the explanation. Why electron moves from lower potential to higher potential, that is not the explanation for this assertion. So reason and assertion both are correct, but reason is not the correct explanation for the reason. Okay, so answer is option B in this case. Now study the IV graph for 3 resistors of 3 samples of nichrome wire with resistances R1, R2 and R3 respectively. Which of the following is true? So as you can see, there are 3 different graphs. Okay, 3 different graphs. Now as you can see here, volt is plotted across x-axis and I is plotted across y-axis. So that is something which is changed than that the diagram given in your textbook. In your textbook, I was given in along x-axis and y was given along v was given along y-axis, right? Now so what is changed here? First of all, let us understand what is this. So V equals to I R. So what we will do, if V is fixed, then resistance is basically inversely proportional to I, right? So if you can somehow magically fix the voltage V, and if you see for which the current is more, they will have the lowest resistance, right? So what I will do, I will fix the voltage here, say at this point I will fix the voltage here. How? By drawing a straight line. Okay, by drawing a straight line, so that will give me a fixed V, right? Okay, let me consider this point slightly, because I am drawing with my bare hand. So this is my fixed V, this is my fixed V. Now for this fixed V, which current is maximum? So as you can see, this current R1, the current say I1, okay, this resistance R2, the current is say I2, and this is R3 and the current say I3. Now as you can see, I3 has lowest value of current, I2 is between, I1 is a maximum amount of current. So as I said, more the current, low is the resistance, less the current, more is the resistance. So R3 is definitely bigger than R2 and R1. So R3 greater than R2 greater than R1. So this is the correct answer. Okay, so this is a very tricky question, very imaginative question, very thoughtful question. You need to understand how to solve such question. If you know, then only you will be able to answer this question. Okay, this is taken from your NCERT exemplar book. So if you are not solving this, you have to start solving that book. Now the resistivity does not change if the material is changed, the temperature is changed, the shape of the resistor is changed, both material and temperature are changed. So resistivity depends only on material and temperature. Okay, so if you change material or if you change temperature, definitely resistivity will change, but it is independent of the shape of the resistor. So resistivity is obviously not change if you change the shape. If you make it longer, if you make it smaller, if you make it thinner, does not matter. Resistance will change, resistivity will remain same. Now, a cylindrical conductor of length L and uniform area of cross section A has a resistance R. Another conductor of length 2L and resistance R of the same material has the area of cross section. So both resistors have the same resistance R. Okay, for first wire okay, rho L by A. Length is L, so this is actually looks like I, but actually it is L. So rho L by A, right? Resistance for first conductor. Now for the second conductor, they said the same resistance is there. Resistance should be R. Okay, same material is there. Material is same, so rho will be same. Okay, but the length is 2L, and the area we do not know. Say this area, say A1. We are trying to find A1, A dash, whatever you are comfortable with. We are trying to find this value of A1. So what we will do? This rho cancels, L cancels. So 2 by A1 is equal to 1 by A. Okay, so 2 by A1 is equal to 1 by A, or A1 by 2 is equal to A, or A1 equals to 2A. So this is the answer. So it will be 2A. Right? Now next question, the commercial unit of electric energy is, the commercial unit of electric energy is kilowatt hour. That is how our electric bills are generated and charged upon, right? So kilowatt hour is the commercial unit of energy. Now let's move on to the short answer type question. If the potential difference across two ends of a conductor is 5 volt and current through it is 0.2 ampere, then what is the resistance of the conductor? So voltage is given as 5 volts and current through it is given as 0.2 ampere. Okay, so V equals to IR, okay, R equals to V by I, or V is 5 volt divided by 0.2, this sorry, not 10, my mistake. So you can do it 50 by 2, that is 25 ohm. Okay, unit is very important, don't forget to give the unit. Okay, so 25 ohm is the resistance of the conductor. Next question, in the given circuit, calculate the power consumed by inverts in the resistor 2 ohm. So in this given circuit, you have to calculate the power consumed by this 2 ohm resistor. So what to do? First we will find the current in the circuit. How can we find the current in the circuit? Okay, so these two resistances are connected in series. So if these two resistances are connected in series, what is the equivalent resistance? The equivalent resistance in this case is 1 plus 2, that is 3 ohm. Okay, so resistance is equivalent resistance is 3 ohm. So what is the current? Current is basically 6 divided by 3, that is 2 ampere. Right, now what is the power consumed in the resistor 2 ohm? So power consumed in resistor 2 ohm is basically I square R. That is the easiest formula that I can use in this case. Okay, VI is not applicable, then you have to calculate V again, but instead of calculating V, I will directly use I square R. I is constant for both the resistances. Both resistances connected in series, that means same current is flowing. So I square is basically 2 square and resistance R is 2. So it will be 4 times 2, that is 8 watt, sorry, joule per second, or 8 watt. Okay, so 8 watt is the answer. Next question, draw a schematic diagram of a circuit consisting of a battery of 4 1.5 volt cells and 5 ohm resistor, a 10 ohm resistor and a 15 ohm resistor, and a plug key, all connected in series. So let's connect it, draw that. So all connected in series, 5 ohm, then we have a 10 ohm, then we have a 15 ohm. All connected in series. There is a plug key. We have 4 1.4 battery. Okay, so 1.5, 1.5, 1.5, 1.5. So what is the total voltage? Total voltage is equals to 1.5 times 4, that is 6 volt. Okay, basically adding all of them, you will get the total voltage, right? Now the electric current passing through the circuit. So what is the current passing through the circuit when you close it? So what is the electric current passing through the circuit? For that we have to first calculate the resistance. What is the equivalent resistance? 5 plus 10 plus 15. So that is 30 ohm. Okay, 30 ohm is the equivalent resistance. So what is the current? I is equal to V by R. V is 6 volt and this is 30, 1 by 5. So 1 by 5 is 0.2 ampere. Okay, so 0.2 ampere is the current in the circuit, right? Now part 2. What is part 2? Potential difference across the 10 ohm resistor when the plug key is closed. So when the potential difference across 10 ohm resistors, potential difference across 10 ohm resistors is I times 10. So I is 0.2 times 10, that is 2 volt. Okay, so this is the answer for this question, right? 0.2 ampere, 2 volt and 30 ohm. And this circuit diagram. Okay, this is the problem. So all these are connected in series. Now next question, a potential difference across two ends of a circuit component is decreased to 1/3 of its initial value when the resistance remains constant. What change will be observed in the current flowing through it, and name the law which helps us to answer this question. So first of all, we know that V is equal to IR, and initially in first case current is basically equals to V by R. This is case number 1. Now case number 2, what happens, what you have done, you have to calculate the new current when the voltage is reduced to 1/3. So new voltage is V by 3, that is 1/3 V by R. Now what is V by R? V by R is I, so I dash equals to 1/3 I. So current will also reduce to 1/3. So when you change the voltage, you decrease the voltage to 1/3, the current will also decrease to 1/3. Okay. Now what law we are using here? Obviously we are using Ohm's law. What is Ohm's law statement? Ohm's law states that when temperature and other physical constants remain same, the voltage is directly proportional to the applied current, right? When temperature and other physical condition remain same, the voltage is directly proportional to the applied current. So V proportional to I, or V equals to IR. Here R is the constant of proportionality called resistance, right? This law you have to state the entire statement. Okay, so this is the discussion we had. Next question is long answer type question. In the given circuit A, B, C, D are 4 lamps connected with the battery of 60 volt. Analyze the circuit to answer the following questions. Okay, A, B, C, D. Okay, now what kind of combination are the lamps arranged in this? So as you can see in this case, all the lamps are connected one after another. They all share the same starting point, okay, because they are connected using a straight line. So that means no resistance involved. So they are connected in parallel combination. So if they share the starting point, as I said in the past, that if they are sharing the starting point, that means they are connected in parallel combination. So correct answer is parallel combination. Explain with the reference to your above answer, what are the advantages any two of this combination to the lamps. So what are the advantages? First of all of them are consuming same power. So advantages is they are consuming they are not consuming same power. What I can say, they are utilizing the maximum possible power. Utilizing max power. Okay, next is if one is fused, the rest will continue to function, right? Even if one is fused, the other one will continue to function. That is the beauty of parallel combination. Next is explain with proper calculations which lamp glows the brightest. So to show which lamp glows the brightest, what we have to do, we have to first we have to calculate the power. So P1 is equal to VI1. Okay, so what is V? V is 60 volt, I is 3 ampere. Okay, so P1 is equal to 60 times 3, that is 180 watt. P2 is VI2, which is 60 times 4, that is 240 watt. P3 is VI3, 60 times 5 equals to 300 watt, and P4 is equal to VI4, 60 times 3, that is 180 watt, right? So these are the, if you remember, this is the currents. So this current times this VI, right? Y, so Y, you have to calculate Y for all of these cases. That's how you can calculate which bulb is glowing the brightest. So bulb C is glowing the brightest from our calculations. Next, find out the total resistance of the circuit. So how can you calculate the total resistance of the circuit? So you can do that in two ways. Either you can calculate the individual resistances, then apply the law of parallel combination and do it, or you can do it in a smarter way. What is the smarter way? We know that this is the I that is flowing in entire circuit. If the current that is flowing in the entire circuit is I, then that I should be equals to sum of all these individual currents, right? So what is that value I? I is basically sum of all the currents, I1 plus I2 plus I3 plus I4. So 3 plus 4 plus 5 plus 3. So it will be 3, 6, 6, 10, 15. So it will be 15 ampere. Now if we can construct an equivalent circuit, having only one resistance with the battery of 60 volt, okay, and the current in the circuit is equals to this current I, then definitely this will represent the total resistance of the circuit, right? That is the beauty of converting it into an equivalent circuit, right? So in this case, obviously this is the answer. So let me highlight that, bulb C. Now this is the last question, last part of the question. So V is equal to IR, or R is equal to V by I. Now V is 60 here and I is 15 ohm, so it will be 4 ohm. So the equivalent resistance in this case is 4 ohm. Okay, simple, not super difficult. This is from one of your previous year questions. So I hope you enjoyed this. Last question of today's lecture. A current of 1 ampere flows in a series circuit containing an electric lamp and a conductor of 5 ohm when connected to a 10 volt battery. So the containing electric lamp and a conductor of 5 ohm. So let me construct the diagram. So we have a electric lamp and we have a conductor of 5 ohm, and they are connected to a 10 volt battery. There may be some plug keys etc involved, but we are ignoring that. Okay, when connected to a 10 volt battery, calculate the, what is the current? 1 ampere. 1 ampere current is flowing. Current is equals to 1 ampere. Okay, calculate the resistance of the electric lamp. So first we have to calculate the resistance of this electric lamp. So what we can do is we apply the Ohm's law. So what is the total resistance? Total resistance of the circuit is basically addition of these two values. So R plus 5. This is the total resistance. Now what is the current? Current is equal to V by R, that is given as 1 ampere. Right, so V is 10 volt, that is equals to R, equivalent in this case, that is 5 plus R. So from here you can say that R is equals to 10 minus 5, that is 5 ohm. So the resistance of the lamp is 5 ohm. Okay, very simple question. Next up part is the slightly difficult. Now if the resistance of 10 ohm is connected in the parallel with this series combination, what change if the current flowing through 5 ohm conductor and potential difference across the lamp will take place? Give reasons. Okay, so first of all, you have a 5 ohm lamp. Okay, now I am drawing the lamp as resistance only so that you are comfortable, and then again a 5 ohm resistance, right? This is the lamp, this one the lamp, this one the resistance. Now what they have done, they have said that you have connected a 10 volt 10 ohm resistor in parallel to them. Okay, now what will happen? First of all, as you have added the parallel combination, the current through both components will decrease. Okay, current through this will decrease, total current will change, the effective resistance will change. Because the change in effective resistance, the current will change, and because the current will change, the potential difference might change. That you have to calculate. Okay, you have to calculate how the resistance is changing. So first, what is the equivalent resistance? Here we have a 10 ohm, so these two are in series. So these two are in series means the equivalent resistance is 10 ohm, and they are again connected with another 10 ohm in parallel. Okay, so what is the equivalent resistance? Two equal resistances connected in parallel, the equivalent resistance will be half of that. I have said that during my lecture. If you missed it, you can check my lecture, yesterday's lecture, okay, in revision video. Okay, so this is the parallel combination. So now we can simplify the entire circuit into this 5 ohm resistor, 10 volt. So what is the current in the circuit? Now the current in the circuit will be 10 by 5, that is 2 ampere. So 2 ampere current will flow in the circuit. So total current in the circuit will be 2 ampere. Now as you can see, both of them have equal branch resistances, right? This one will also have 10 ohm, this one will also have 10 ohm. So two equal parts of two equal resistances. That means this 2 ampere current will be divided into 1 ampere here, 1 ampere here. Okay, so basically when you apply 10 ohm, particularly for this case, okay, the current through this branch remains unchanged. So this branch current remains unchanged. Because of that, there will be no change of the power or the current that is flowing through this 5 ohm resistance. Only in this case, if you add any other value, definitely it will change. Right, so I hope you understand this problem and the solution, and I'll be back with a new solution, new lecture maybe in future. But before I go, you have to listen to me that we have Diksha Scholastic Aptitude Test, that is DSAT, which is getting conducted every Sunday on our Diksha campuses. What is that? That is basically based on 3-part series. First, there will be a lecture, 1 hour lecture and doubt clearing session. So there will be some topic taught by an experienced teacher, and you will be given an opportunity to clear your doubts. And once the lecture is over, there will be a mock test based on that lecture, and once the test is done, then based on your test results, there will be a counselor will guide you for your better future. What will be your choice to pursue in future? Okay, whether you should pursue for the top engineering colleges across India for JEE exam, or you should focus for top medical colleges colleges across India for NEET exam, or you should choose top engineering colleges across Karnataka the KCET exam. So they will guide you that you are suitable for this course. You can opt for this course, and only thing that you have to do, you have to fill up this form. Link of this is given in the description, and I am saying bye. We'll be back in a future video.